Uh-huh. Yeah. Um, I mean, it's still 4/1, but the reason is that you think about the original height, lowercase
Okay.
h with the capital letter H, which means the original ratio of the height, right? So which is 4/1. Okay. And then you think
Yeah.
about after the rise, because these two spherical marbles, they have the same volume, which means that once
Yes.
you submerge these two spherical volume, then you got a new, you have a new, let's say, new cone, right? Then this new cone should also have the same volume, right? And then which means
Yes.
that, so let's just call the height of the new cone is still, let's say, h prime and h prime, okay? Because they still
Okay.
have the same volume, which means that their height different, the ratio of their height is still 4/1, right? And
Okay.
then what's this problem asking about? Is asking about the rise, right? Which is the h prime minus h over h prime minus h, right? The ratio
Yes.
of this. Okay. So then actually this is one of the properties of, let's say, what's that, the ratios, right? Because you have you think about it in this way, so as if you're thinking about a mixing problem for a solution, right, in chemistry. For example, you missed, so there's like a 50% of, let's say, sodium solution. Have you learned about chemistry, by the way?
Not really. Not
Anyway,
really in chemistry.
so yeah, anyway, so let's just think about sugar, right? So you think about it, a water that contains sugar, that contains 50% of sugar, right? So let's just call it sugar water. Okay. So then if you let's say, after you want to kind of like put some, pour some new liquid in it, but you still want this water to contain the same level of sugar content, then what's the, let's say, the concentration of this new sugar water you should be pouring into, then if it doesn't want to change the concentration of the original one. So what liquid should you be pouring into this old bottle then? So suppose this is contains the 50% of sugar water, right? And
Okay.
you kind of like pouring a new kind of liquid. But the idea is that you want this sugar level to maintain the same amount, right? Then what
Okay.
liquid should you be pouring into then?
Wait. So they both have 50 and you put a different liquid. Wait, what are you asking for?
Hmm. Uh-huh. Yeah, I mean, if you think about it this way, if you're just pouring water that doesn't contain sugar, right? The end result is that you will end up diluting this original sugar
You
water.
dilute it, right? Yeah.
That's right. But if you wanted to maintain the same amount of sugar, the sugar level, you should be pouring into the same concentration of sugar
Yeah, you
water.
should be putting like more 50%.
That's right. So if you, let's say, pour into 100% sugar water, you end up increase the sugar level, right? So it's the same idea here. So which means that once so the rise should be also a 4/1 ratio, right? Because if it's not a 4/1 ratio, then you end up changing the ratio. That makes sense to you?
Yeah.
Uh-huh.
Okay, that makes sense.
Yeah. Uh-huh. So it's pretty much the same thing, right? You think about, let's say, the original small h over larger h is 4/1. And then you kind of wanted this new solutions to have the same ratio, 4/1, right? And then you're adding something. So in order for them to maintain the same ratio, so you should have the the difference also having the same ratio, right? So this difference is kind of like the solution mixture problem, right? See, so you want them to maintain the same level. So they're still 4/1. So yeah, the answer is E.